Here is a robust summary of D block elements and their reactions with water, with hydroxide ion solution, with excess ammonia and excess chloride ions. Chromium produces the chromium ion solution when added to water. It's violet in color and has an oxidation state of +3. When hydroxide is added to it, it forms a blue-green color precipitate, chromium 3 hydroxide. When excess ammonia is added, it forms a purple color amine complex, CrNH3 6 3+, and when excess chloride is added, it forms this chlorocomplex, a blue-violet chlorocomplex, CrCl6 3-. When excess hydroxide is added, however, it forms this hydroxide complex, a blue-green color hydroxide complex, CrOH6 3-. When manganese is added into water, it forms a pale pink color solution of manganese. When hydroxide is added into this pale pink manganese solution, it forms a white cream color precipitate, manganese 2 hydroxide. This hydroxide, it does not dissolve upon further addition of hydroxide and further addition of ammonia even. When excess chloride is added into manganese, it forms a green-yellow color chlorocomplex, MnCl4 2-. Now we have iron. We have the ferrous iron and we have the ferric iron. Each of these can be oxidized and reduced into each other when oxidizing and reducing agents are added appropriately. The ferrous iron is pale green in color, while the ferric iron is yellow-brown in color. When hydroxide is added, it forms their respective hydroxides. Ferrous ions form ferrous hydroxide, which is dirty green in color, while ferric ions form ferric hydroxide, which is red-brown in color. These are precipitates. And these precipitates do not dissolve in excess hydroxide or excess ammonia, as shown here. When excess chloride is added into the ferrous and ferric ion solutions, it forms their respective chlorocomplexes, which are yellow in color. Both of them are yellow. Here it's 2-, here is minus. And now we have cobalt. When cobalt ion solution is pink color, and it has an oxidation state of +2. When hydroxide is added, it forms a pink color salt, a pink color precipitate, which is cobalt 2 hydroxide, as you see here. If excess hydroxide is added, however, it forms this deep blue hydroxide complex, COOH4 2-. If we were to add excess ammonia, however, it forms its respective amine complex, hexaamine cobalt 2 ion, which is yellow brown in color. If we were to oxidize it with some oxidizing agent, we get this brown red color hexaamine cobalt 3 ion. If we were to add excess chloride into the cobalt ion solution, we get this chlorocomplex, which is blue color, COCl4 2-, tetrachloride cobaltate 2. Now let's go to nickel. Nickel is a green color solution. Nickel forms a green color solution, and when hydroxide ion is added into the nickel ion solution, it forms this green color precipitate, nickel hydroxide, and it doesn't dissolve in excess hydroxide. However, if we were to add excess ammonia, it will form nickel, this amine complex. It's blue in color, hexaamine nickel 2 ion. It's blue color. And if we were to add excess chloride ion into nickel, we get this chlorocomplex, tetrachloride or nickelate 2 ion. It's yellow color. It's a yellow color solution when in aqueous medium, and it's blue color in alcoholic medium. It's a rather interesting property about it. Now we have copper. The copper ion solution is pale blue in color, and when hydroxide is added, it forms a blue color precipitate, copper 2 hydroxide. It doesn't form any hydroxide complex when excess hydroxide is added. However, if we were to add excess ammonia, copper forms this dark deep blue color amine complex, tetraamine copper 2 ion. And copper also, just like nickel, forms a yellow color chloride complex, tetrachloride cuprate 2 ion. Zinc is rather easy to remember because it produces a colorless solution. When we add it to hydroxide, it forms a white precipitate, zinc hydroxide. When excess hydroxide is added, it forms this colorless hydroxide complex, ZnOH4 2 minus. If we were to add excess ammonia, it produces this amine complex, tetraamine zinc 2 ion. Excuse the mistake, it is actually colorless. It is colorless like all the other zinc complexes. And zinc also forms a chloride complex when added to excess chloride ions, and it is also a colorless complex, not yellow. Now we can differentiate between copper and nickel by its hydroxides only. Nickel forms a green color hydroxide, copper forms a blue color hydroxide. Green hydroxide, blue hydroxide. They both form blue color amine complexes and yellow color chloride complexes. And then we have the cyanides. Nickel, when reacted with cyanide, forms a light green color precipitate, nickel cyanide. But when excess cyanide is added, it forms a yellow color complex, as you can see over here, tetracyanide 2 ion. And as we can see here, if we were to add cyanide ions into the ferrous and the ferric ions, we respectively get the yellow green ferrocyanide and the brown color ferricyanide. If we were to add cyanide ions into the cobalt and the manganese solutions, we will get a purple color complex for cobalt and a blue color complex for manganese, and that is the robust summary of D block elements.